process is the same. It's just a little bit different because the variables are involved. I know anytime we bring up these letter things in math, kids get all crazy, but please don't. It's really simple. Again, we're going to use the prime factorization approach. So we're going to do the prime factorization of those monomials. Well, hopefully these are really easy. I'm starting really simple. I don't even know if we need to make a factor tree for these, but we can if you want. All we're going to do is this. 4, I'm pretty sure most of you know, is 2 times 2. The next thing might be, yo, Goodman, I don't know what to do when I'm dealing with those variables, a squared and b. All you're going to do is break down into as prime as you can get, is what I like to call it when I say as prime as you can get. You don't know what a is, but you can break a down and say, I know the factors of a are a and a. So all I'm doing is breaking that variable down into a times a, because that's what a squared means. B is, well, just b. I'm going to do the same thing for 6. This is 6ab squared. So again, if I think about the prime factorization as a 6, it is 2 times 3. Hopefully I don't have to make a tree for that. If you have to, go ahead. Then I'm going to break down the variables in the same manner. A, well, that's just a. B squared is just b times b. Okay, that's as prime as I can get. So when I go to find the GCF or the LCM, well, guess what? It's the same process. GCF is that intersection. So when I go to do the GCF, I'm going to find the intersection. Well, they both share the 2. They both share an A, and they both share a B. That means that my prime factorization, or I'm sorry, my greatest common factor from the prime factorizations is going to be 2a and b put together, which is 2ab. It's that simple. Least common multiple, this is where I have to do the union, which means I'm going to have to put all this stuff down. Well, I need that 2. I'm going to need another tier 2 to cover that 2. I need a 3 to cover that 3. I need the a to cover those. I need another a to cover that one. I need a b to cover that one. And then I need b to cover both of those. It's kind of one of the reasons I like to circle that GCF numbers, because then you're only getting it once. They already share it. You don't have to list it twice. So if I do that, 2 times 2 times 3, I'm looking at 12. A times a is a squared, and b times b is b squared. So my least common multiple is going to be 12a squared b squared. I know, you're probably looking at it going, oh, I don't like it, because I'm putting letters in there, variables, but the process is the same. Let's do another one. Actually, probably squeeze it in just right here. Let's do GCF and LCM of 14xy squared, and let's go with something like, let's go with 10x cubed y to the 5th. GCF LCM. So I'm going to start with my prime factorizations. So I'll start with 14xy squared. Again, 14, if you have to do the factor tree, please do. We've been through that. I'm not going to go ahead and do that. Plus, I know that 14 is the factors of 2 times 7, and those, of course, are prime. There's an x in there, so that has to come along. There's a y squared, so that's y times y. Let's do the 10x cubed y to the 5th. So prime factorization of 10 is 2 times 5. Again, if you need to do the tree, go ahead. I don't think we need to for these as of yet. Now, when I go to do my variables, well, they all have multiples. So there's x times x times x, and then there's y times y times y times y times y. So I look at that and go, okay, GCF is the intersection. What do they share? So my GCF has an intersection. Well, they both have 2. They both have an x, and they both have a y. Actually, they both have 2 y's. Look at that. So I've got 2x, y, and y. So I'm looking at GCF of 2x, y squared. Hopefully that's simple enough. LCM, least common multiple. Whoosh. Now I've got to have all of that stuff in there. Okay? So I need a 2. That'll cover this guy that is circled. I need a 5. I need a 7. Covers those two. Need an x to share there. Don't forget you need these two x's in there. You need this y that they share, this y that they share. So there's two y's. Then I also need these three that come along. Ooh, scary, right? Let's put that all together. 2 times 5 times 7, that's 70. Then I have x times x times x, which is x cubed, and then y times y times y times y times y is y to the 5th. So my least common multiple is 70x cubed y to the 5th. I'm wondering if anybody is noticing a certain trend. In other words, the connection and my final result of my GCF and my LCM. And when we look at these, well, hopefully we're drawing some sort of connection. Let's do another one, and then we'll go ahead and discuss another way to come up with it. We're going to find the GCF and the LCM of 30a squared b cubed c and 48ab squared c squared. Whew, a lot of work there. So the first thing we're going to do is we're going to start with the prime factorization. 30a squared b cubed c. If you need, you may go off to the side and do your prime factorization factor tree. So let's go ahead and take 30. We will break that down. If I think about 30, I think 15 times 2. I recognize that 2 is prime, 15 is not. 15 busts down into 3 and 5. They are both prime. That tells me that the prime factorization of 30 is 2 times 3 times 5. Going to the variables prime factorization, or as best as we can tell, is a times b times b times b times c. Doing the same thing with 48. I'm going to come off to the side here, take care of 48, see if we can squeeze it in here. So when I think of 48, I think 6 times 8. Neither one is prime. So I'm going to take 6. I'm going to bust that down into 2 times 3. They are both prime. I'm going to take 8. I'm going to divide that down into 4 times 2. 2 is prime, 4 is not. That breaks down into 2 times 2. So now I have my prime factorization of 48ab squared c squared. Let me get that down here. I can get my marker out. 48ab squared c squared. That guy will factor into 2 times 2 times 2 times 2 times 3. 2 times 2 times 2 times 2 times 3. And then when I go to my variables, I have a. B squared would be b times b. And then my c squared would be c times c. Now, all that work to now come up with the GCF. Remember, your GCF is the intersection of those sets. Find the things that intersect. They both have a 2. They both have a 3. I'll make a little swoopy there. They both have 1a. They both have actually 2 b's. And they both actually have 1c. So that tells me that my greatest common factor is 2 times 3 times a times b times b times c. That will simplify into 6ab squared c. Going to my LCM, now I need the union, which means I need everything that's there. So to cover everything, I need a 2 that takes care of both of those. Then I need 3 more 2s to take care of that guy. I then need a 3 to take care of that one. I need a 5 to take care of that guy. I need an A to take care of that guy. I need another A to take care of both of these. Then I need 2 B's, take care of both of those. I need a B to take care of that one up there. I need a C to take care of that one down there. And then I need 1 more C to take care of both of those. So that comes together as 2 times 2 times 2 times 2 times 3 times 5 is looking like 48 times 5. 240 is 240. And then I'm looking at A times A is A squared. I'm looking at B times B times B, which is B cubed. And C, which is C squared. So LCM, GCF. I want to stop for a second, and I want you to realize a couple things here. Thing 1, well, all this variable stuff is just time consuming. Is there an easier way? So what I'm going to do is this, is I'm going to point out the fact if you look at the GCF, if you look at the variables of the GCF actually are the smaller of the two. Like for instance, you had a squared and a. The least amount there was the a, so that was the one there. Look at the b's, b cubed and b squared. You went for the least amount there. C and c squared, least amount there. The LCM is the opposite of that now. It's the most. A squared and a, largest amount is a squared. B cubed and b squared, cubed is larger, there. C and c squared is larger, and there. Keep in mind when I say smaller and larger, I'm talking about just the exponents, not the value of what those things would wind up being after you square or cube, because it all depends if it's positive or negative, to tell you the truth. Anyway, that's GCF, LCM using monomials. I hope that makes sense. I'll talk to you later.